I'm going to stop and restream again because the information display is not right. Just want to do that. Looks like the stream is okay, but I just need to change the information of the stream. Right, now it's good. Information now is displayed correctly. I think we can start in the 1 minute. Let me just add this real quick. It's all done. Now we can start. We have a few on the live stream. So if you have any question, just put on the chat, and I once I see the problem, I can do those problems. I also have a few questions on the email, so I will certainly will do those problems as well. So the question will be over the lab one, of course, and also on the homework. Right. So I have a question on the homework. So. So because they're on this kind of on the first test, the material kind of close together, so I would just jump back and forth between the question. There would not be any particular order. So first I have the question section 7.4, 33 and 41. Let me have the problem first. Right. Just need to get some paper. Right. Right. First, section 7.4, number 33. Put this. Right. Find the area between the function. And x-axis from 0 to 5. Right. So first we have to graph the function. So let me have the get the calculator first. I shall have calculator. So first, graph the function 2 minus 2x squared and from 0 to 5. So kind of like that. Let's put this calculator over here. Yeah, only from 0 to 5 though, so 5 is about here. So first we're going to need to find the intersection. By the way, on the test the graph will be given, so you don't have to worry about this. The intersection here is between the function and the x-axis. So pretty much the intersection we find the intersection by take the function and the x-axis, which is x equal to y equal to 0. We don't need the calculator anymore. And now we just solve for x. So that gives us 2 equal to 2x squared, or x squared is equal to 1, so x equal to plus or minus 1. And indeed the intersection here will be negative 1 and 1. The area we want is from 0 to 5, so pretty much this part. And of course the graph will get very further down here, but so pretty much that. So on this one we can use the calculator. So the first one, we find this area, which will be the integral from 0 to 1 under the function 2 minus 2x squared dx. And now we just do that, and we need the calculator back. So I need to hit math, option number 9, and now we just enter that in. 0, 1, 2 minus 2x squared dx. Actually I will just do the integral first, and that is 1.33. If I convert that to fractional, it's 4/3. Yeah, we should do this first. Now it is positive, so the area is going to be 4/3. Yeah, so for that portion is 4/3. Now we find the area over here. Let's just do the integral first from 1 to 5. Let me switch to the older calculator because it might look differently. So right. Actually, I just switched to the different mode. Right, so I have that. So do the same thing, hit math. Math, option number 9. And now we enter the function 2 minus 2x squared and then the variable is x from 1 to 5. It looks differently, but it does the same thing. And we have that. Let's convert that to fraction. Negative 224 over 3. So that is the definite integral. But we want the area. So the area is going to be positive only. Yeah. So we do the definite integral first, whether it's positive or negative. The area is going to be positive always. And we're just going to add those two together and we have it. So 224 over 3 plus 4 over 3 is 228 over 3. That is 76. So just find the area by first find the integral. If the integral is positive, that will be the same. If the integral is negative, turn to positive because the area must be positive. Right, so that is 33. And then 41. 41 kind of the same thing, but we have the graph. So on the test, you more likely see number like 41 because the graph will be given. Look like intersect at 3 here and 2 here. The function is y equal to 4 minus x squared. Right, so that is the area. So right, so we will do the same thing. First, the whole area that is above here, we will set the integral. The integral of this function that goes from the graph. We should see that it goes from 0 to 2, and we do that first. Whatever that is, if it is negative, we turn to positive. If it is positive, we're going to keep positive because this problem asks for the area. Both of these questions ask for the area, so very important. That is not the integral. So anyway, we do this. So turn the calculator back on. Change the contrast. Right, math option number 9. The function is 4 minus x squared, where x goes from 0 to 2. That is 16 over 3. And that is positive, so the area is equal to that. And now we do for this portion. Also the same function. But it goes from, on the graph, it is from 2 to 3. So we have the function enter already. All we need to do is, if we hit the second enter, and second enter again, we'll go back to that, and we just need to change the limit. So second and enter will give you the previous entry. And so on this calculator, that's how we do it. So we just change the limit to 2 to 3, and we have that, and change the fraction negative 7 over 3. This looks like one of the review, the lab question, but anyway, so we find the area be equal to positive. The area can only be positive. So we use the definite integral to get the the values. If it's positive, the area will be positive. If it's negative, the area is still positive. And we just add these two together. Will be 23/3. Right. So that is the area of the shaded region. On the test, you will be given the graph. Just need to set up the integral, determine if it's positive or negative, and just go from there. Right. Right. Sorry. So that was 32 and 41. Right. So as always, if you're watching the live stream, thanks. And if you have any question, please just put on the chat. I would um, I should disable the chat for those people who watch later. I would disable the chat so you will not see the chat on the video later. Right. So, have any next question, please? Right. Right. So I will do 11 first because it is easier to do. So I will turn off the calculator for now because we don't need that. I need to change the contrast. It kind of doesn't look very. Right. So I'll do 11 first and then go back to 10. First on 11, there's no product rule or no quotient rule, no chain rule for that matter, in the integral. So there's substitution, but it's not substitution here. We're going to multiply it out because in that case we just have the powers to contend with. So 3x times x squared, that is 3x cubed. And then x squared times x to the negative 3. When we multiply two things with the same base, we're going to add the exponent. So we have 2 minus 3 will be minus 1. Dx. And it will be easy after that. So integral for x cubed, it is x to the 4th over 4. And for x to negative 1, it is ln of x. And the plus sign here will stay. And we just have that. 3 over 4. The 4 is still at the bottom. So x to the 4th. So it will be just that. Now we go to 10. Actually, the t cube is easy to do, but that one might require a substitution. So in that case, let's split this into integral. So we have t cube dt, and then e to the 5t dt. Let's do them separately. This one, which will just have t to the 4th over 4 plus a constant c. But we're going to do this anyway, so that will be another constant. So we just have that for now. This we need to use the substitution. So put that 5t, and we take derivative. And multiply dt and divide by 5, so we will have du over 5 is equal to dt. This substitution is simple enough, although there's a shortcut to this, but we'll get there in a minute. Anyway, so that means for this term, just kind of separate now. Right. Just have to write it again. Equal to e to the u dt is du over 5. So take the 5 outside, and we have e to the u du, which is 1/5 e to the u plus c. So that is for this term, and that is for that term. So in general, I just write the answers here. So we have t to the 4th over 4 plus 1/5 e to the u plus c, and finally u is 5t. Yeah, so this one a little awkward because we have the t cube doesn't require any substitution, and e to the 5t require a little bit of substitution. By the way, in the book, they just say that when we have e to the kx dx, integral of that is e to the kx divided by k plus c. I don't require you to memorize this. So that's why we have to do the substitution like this. But the substitution only applies for the second term. The first term doesn't require substitution. Anyway, the answer is going to be this. It's going to be like that. Right. Since we're here, I do have question on 11, which we just did. 12 and 13 as well, so we go to 12 and 13, so we don't have to turn the pages. So we go to 12 and 13. Kind of the same thing. Right, let me change the list. And by the way, you don't have to wait. Just put the question on the chat, and I will just keep checking. Right, 12 and 13. 12 and 13. This is the initial value problem. right? 12 and 13. So pretty much in the initial variable problem, what we have is a derivative, a differential equation, and we have the initial condition. By the way, when we say the fixed cost or equal to 10, meaning that when we produce nothing, the cost still $10. So we have to pay that regardless. So that is the initial condition. Right. Our first thing we have is the derivative equal to 4x minus 3. So derivative is 4x minus 3. To get back to the function, we have to do the antiderivative or the integral. By the way, just checking, is the video and audio quality okay? I just want to make sure that it's working. Right. Anyway, so we do that, and we integrate 4x will be 4x squared over 2. Integral of a constant 3 is 3x plus c. So simplify this, 4 divided by 2 is 2x squared minus 3x plus c. Alright, so that's just, thank you. So that's just the function with the constant c. Next, we have this initial condition. Meaning that if the function is equal to 10 when x equal to 0, so we're going to put 0 in for x. So that cancels, so c equal to 10. Right, so now c equal to 10, and we just need to substitute this in here, and we have the function. Right, so that is that one. The next one is the same thing. We have derivative, so to get back to the function, we integrate, and square root is equivalent to the 1/2 power. That gives us x to the 3/2 over 3/2 plus c. Right? I hate numbers. Anyway, so divide fraction is multiply reciprocal, so 2/3 x to the 3/2 plus c. Right. So integrate, we have that. Now we just need to use the initial condition. Initial condition is this. By the way, that is the terrible way to do this, because we have the cost function and then we have another constant c. So usually for that case, I mean for this one too, change that to d. Okay. Yeah, that's better. I could use k or any other constant, but since I already wrote that, so it's better to just have a different constant. Right, but just a constant anyway. So that plus d instead of c. Now we'll make the function equal to 40, so put 40 in here, and this is where x equal to 9. Right, Now we bring back the calculator. Right. So we have 2/3 times x to the 3/2 x I mean 9 to the 3/2 is 18. So this is 40. 18 plus d, so d is 22. So put that in back in here. So we have the cost function is equal to 2 over 3 x to the 3/2 plus 22. Right. Next we have 22 and 23. I will update the list in the bit. So, that there. By the way, I need to post an announcement on that side just a little bit, because in class we did not cover section 7.5, so the test will be only up to number 28 on the left. So let me write this real quick. Right. Then let me put the calculator away. Right. I right. That is easier. Right, so 22, 23, sorry. Right, so we have the properties of the integral. So let me write out those properties first over here, and there will involve three properties. The first one, if we go from the same number from a to a of any function, it's going to be 0. That is a. Next, if we interchange the limit, we go from b to a instead, it is going to be negative where we interchange the limit. And finally, we can split. So from a to b, I have to write very small here for this one. We can go from a to anything, and then from whatever that, go to b. Right. So we have that. Now, actually, we can put any numbers here and here. As long as those numbers are the same, it is okay. C doesn't have to be in between. It doesn't have to be in between A and B. So just any number will do. So this is what we want. We want from 5 to 9. I mean 9 to 5. And so the problem we are given, we have from 1 to 5 and from 1 to 9. Obviously we see 5 and 9, which is good. What we don't see in this is the 1. So the 1 is new in this problem. It doesn't appear here, but both of this. So we use this property and we will split the integral into 2. We start from 9 to something, and from that something we go to 5. Now we can put any numbers here, but since the problem we have 1, so we're going to use 1. And now it's a lot clearer. Now we know that from 1 to 5 the integral here is going to be equal to 12. And here we have from 9 to 1. We are not given that. We are given from 1 to 9 instead. The limit interchange here and here. So interchange. Because of that, originally it is 15, but because we interchange the limit, we throw an extra negative sign. Yeah, so that will give us 1 to 9. Here from 9 to 1 we have the negative. And we just pretty much add these two together. Negative 15 plus 12 is going to be negative 3. Yeah, so we just need to split the integral in 2 using the number. So we have to look at the problem, and well, we should be able to tell where do we have to split. Those two numbers should be the same. Right. The next properties, I think I mentioned this before, but we can notice that now we have the difference here is those two integrals. They have the same limits, but the functions are different. So in that case, what we can do is we can split f from 5 to 9, f of x dx minus 3 g of x dx from 5 to 9. And then the 3 is a constant. We can take it outside of the integral. Take it outside. Right. Next, from 5 to 9 of g of wait. Sorry, this will be f of x. F of x from 5 to 9 is negative 6. We have negative 3. G of x from 5 to 9 is 10. So we have negative 36. So those are the properties of the definite integral. Those are just properties of integral, but for definite integral we have those as well. Alright, since we're on this page, I do have question 24 and 25, so we just go over that quickly and then we go to your next questions. Yeah, 24 is simple, but 25 might be a bit complicated. Alright, 24 and 25. 24 first. So this is just the fundamental theorem of calculus. So let's just write that formula out. By the way, we will use this for the remaining of the class. It's very important. We see this in various applications. Right. Of course, the f of x here is any antiderivative. Right. So first, for this, we have to find the antiderivative. 5 plus x squared will be 5x. X squared is x cubed over 3. And we go from negative 1 to 0. Let's say x goes from negative 1 to 0. Right. And next we just put in the limit. Put in the top first. The top minus the bottom. The upper limit first and then the lower limit. First we put in 0. And then put in negative 1 for x. Right, 0, that obviously 0. Still minus. This is negative 5. And that is negative 1 over 3. So together look like we have negative. And that is negative 16 over 3. And negative. So that's 16 over 3. So that's 24. Straightforward. fundamental theorem of calculus. Now we're on to go to 25. By the way, with that announcement on that side, we still need to do homework for section 7.5. Just need to turn in together with the homework one. So anyway, now we'll go to this one. Similar to a question we have before on number 11. On integral, we do not have product rule or quotient rule, just have the power rule and exponential rule. So first, we're going to split, not split the integral, just split the fraction, that is. Right. So we have x cubed plus 5 over. So we subtract the exponent. 5 minus 2 is 3. And this we also subtract negative 1 minus 2. That's minus 3. So I write that over here. X negative 1 over x squared. We subtract the exponent. Minus 1 minus 2. So that's x minus 3. And because this is 5, minus 2 is 3. So dividing, we subtract the exponent when the bases are the same. Right. Now we just integrate. X cubed gives us x to the 4th over 4. And this is x to the negative 3 plus 1 is negative 2 over negative 2. We do not have the constant c here. Because in the formula we just need any antiderivative. We choose the one with the constant equal to 0. Anyway, of course we can substitute it here already, but I just simplify a little bit before we do that. So we have x 4 to the 4th power over 4 minus a negative, minus divided by negative, so that will be just a plus. Right. Use a calculator on this one. Right, so we have that. So first, okay, make it bigger. Right there. Right. And that's good. First we store let's do 2 first. 2 we store into x, and after that we have x to the 4th divided by 4 plus x to the negative 2 divided by 2. So 4.125. Let's change to fraction. 33 over 80. So I should not do that. Okay, let's just write this out like this first. I put 2 and then minus where we put 1. and then that will be 33 over 8, and then minus. Right, back to calculator. Now we hit 1 and we store into x. And then if we have this calculator, we'll just go back up and highlight it and hit enter, like copy and paste. If we do not have that, we just hit second and enter, second and enter until we have this equation. So we can do this. See, second and enter, second and enter, until we see that equation, that function, and we have that, which is 3 over 4. And now we have 33 over 8 minus 3 over 4. The rest is easy. So that would be 8 and 27 over 8. Right. So that is number 5. Right. Right. Of course, this problem, just a fundamental theorem calculus, doesn't require us to use substitution. When we do 26 to 27, then we have to use the substitution. I think. Right. Of course, 26, but 27 a little more difficult. Right. So first, we use substitution. So we let u equal to something. So we let u equal to this. And then we just solve for du. So we check derivative. Will be derivative. It's just 2x. Multiply the dx over and divide by 2x. So that will give us dx. This problem we do have the limits. Originally we have x equal to 0 to x equal to 1. So I will change the limit as well. When x equal to 0 to x equal to 1, x equal to 0, if we put 0 in for x, we have 1. And when x equal to 1, put 1 in here, we have 2. I should say u equal to 1 and u equal to 2, right? Right. Now the integral, 5x still there. That is the fifth root. 1 plus x squared is u, and dx is du over 2x. The limit do change from 0 to 1. Now it becomes 1 to 2. Right. What we do next is can cancel the x. We take the 2 outside, the 2 at the bottom, so we stay at the bottom. The 5 we stay on top, so we have 5 over 2. The limit is 1 to 2. Just to be clear, we just say u equal to 1 to u equal to 2, or we just say 1 to 2. Right. I see the 5 move out, x cancel, we just have this left. The 2 moving out, the x cancel, so we just have du. So just that. The fifth root we can say u to the 1 over 5 du, and finally the integral u to the 1/5 integral be u to the 6 over 5. 1/5 plus 1 is 6 over 5 over the same thing. The limit now will be 1 to 2. Right, next. 5/2 divided by 6 over 5 is multiply 5 over 6 multiply reciprocal, and we go from 1 to 2. Right, that will be 25 over 12, and then u to the 6 over 5 from 1 to 2, and then we just put 2 in it and 1 in it, so we have 25 over 12. Put 2 in it, we have 2 to the 6 over 5, minus when we put 1 in it, and of course 1 raised to any power is still 1, so we just have, just write like this. Then minus 25 over 12 times 1, or just that. Right, so that is 27. Right. If you just join the live stream, first there is an announcement on that side. The test only cover up to section 7.4, and the lab only up to 28. I think we did 28 in class. Or actually, I think this is like one of the homework questions. It just look differently on this paper. So we have that. Right. And the question 29 and 32, you do not need to do it. I will put that on the lab 2. Alright. Next, just want to go back and do some of the question on the derivative. Even though it is not on the test, but it's rather important. So I have the question 2 on the lab, and after 2 I will do 5 and 8. Right. And of course the derivative, I will not ask this question on the test. But regardless, I do have some question on that. Right, 2. Right. Kind of similar to the same where we find derivative, the integral. However, this we do have the quotient rule. So if we want to, just use the quotient rule. If not, I actually would prefer to just split this in 2. By the way, the function is just that, so I split that in 2. But before I do that, because we're going to use the power rule and all the rules for derivative, so let's write this as a power 1/2. Right. Now we split this in 2. So I split x over x to the 1/2 plus 7 over x to the 1/2. Now this is just the properties of exponent. It's not derivative yet. So, and by default we can say this to the first power. And now we subtract 1 minus 1/2, so that gives us x to the 1/2. Next, this x to the 1/2 will move to the top, becomes negative 1/2. So we have two properties that we use here. The first one is where we divide, we subtract the exponent, and the second one, when we move a power from the bottom to the top, we change the sign of the exponent. Right, so apply to those two. Anyway, only then we take derivative. Now the derivative, just the power rule, will be 1/2 x to the 1/2 minus 1, and then 7. Derivative of that will be negative 1/2 x to the negative 1/2 minus 1. So we end up with 1/2 x to the negative 1/2 and negative 7 over 2 x to the negative 3/2. I think we leave the answer in that form. It's certainly acceptable. Right, so we're going to leave it like that. So that is 2. Right. Now we go to 5. Right. It's not any particular difficult on number 5. Just that this is 8, not e to the x. We know that the derivative of e to the x is just the same function. Now if we have something else, some other base, we're going to end up with ln of a first and then a to the x. Although you need to know those, you need to know this formula also, because you must know this. You need to know this. I will not ask you anything. That is, the base is not e. That goes for number 8 as well. Right. So this first, this we're going to use the chain rule. Put the negative x in the box, and we have 8 to a box, and the box is negative x. Right. Let's just label that u. And now we decompose that into two functions. Derivative of this is -1. Derivative of this, we have to use this formula. This will be ln of 8 and then a to the u multiply with -1. That gives us the derivative. So we will have negative ln of 8 and then 8 to the u, where u is just -x. Yeah, so that. Again, I need to know that, but I'm not going to ask anything that is not, the base is not e. You only have e to the x, e to the something, not on the base. Right, so that is 5. And then we go to 8, because that is also the base is not e. We have log like that, which means this is the common log, but leave that for a moment. Right, 8. Again, we have derivative. Ln of x derivative is 1 over x. Derivative of any other base of x is equal to 1 over x times ln of a. Right. Actually, the formula for that is pretty simple. We start with, I write the proof in a few steps. Let's say the function is log base a of x. The change of bases formula is going to be ln of x over ln of a. That is what we call the change of base. This is coarse algebra or the business math. So we change the base from a to ln. We can rewrite this as 1 over ln of a and then ln of x. And the derivative of this is pretty simple. That is the constant, will stay in front of it. The derivative of ln of x is 1 over x. And thus we have this. Yeah, so the proof is pretty simple as long as we have the change of base formula, which is this one. Right, I leave it at that. By the way, you're not required to, you will not see the problem where the base is not ln on the test. So it's nice to go over that. Anyway, first, when we don't see the base, that default is the base 10. So we use the chain rule for this. So 7x minus 5. We have log base 10 a box, and the box is equal to 7x minus 5. Label that u. Derivative of this is just 7. Derivative of this is 1 over ln of the base. The base here is 10. And then the x, we have u instead. So just multiply. And that is the derivative. So the 7 can multiply on the top. And we just have ln of 10. U is 7x minus 5. So we just have that. Right. Once again, if you have any question, just put on the chat, and I'll see the chat, and I will do those problems. For now, we go to 22 and 21, and we make the comparison between the area and the definite integral. Right. This question, the question asks, use geometry to find the exact values of the integral. What they want is the integral and not the area. So the answer, if we have negative, it is perfectly fine. Right. So we start with the integral. We have the function. Look like this is the function, and we want to go from 1 to 3. So let's look like we want the area that is between 1 and 3. So those area. Right. It is a trapezoid, so it is easier if we divide this into rectangles and triangles. So first, split it right here. So we have a rectangle here. The scale is off. Sorry about that. But we go from 1 to 2 here. So the width here is going to be 2 from 1 to 3. So this side is going to be 2 in length. And the height here, we go from 0 to 3. So that's going to be 3 in length. So obviously 2 by 3 gives us the area is 6. Now that 6. Next, we have this area. This is still 2, and the height here, let's see, it go from 3 to 7. So this is going to be 4. Yeah, the scale makes this a lot more difficult than it should be. And so that gives us 4. So the total area of this trapezoid is 10. Area is always positive, so that's why we have positive. However, the question asks us for the definite integral. So that integral because we have the area that is above the x-axis, so this also positive as well. We don't have that example here, but after number 21 I'm going to do one example that involves the negative integral. Right, so that is 22. 21, the graph is not given, so we have to draw it. So I just say it because the area is above the x-axis, this is going to be positive. Just say positive 10 because of above the x-axis. Right, next. We have the absolute values, which is a v. It goes from 5 to -1. Yes, after this we do one problem and then we go to 26. Because I just want to compare the area and the definite integral. Right. So quickly, this one, the area for this, the width is 5, I mean is 5, so the area of a triangle is 1/2 base times height 25/2, and that is the area above the x-axis, so it will carry the positive sign. This goes from 0 to 5. Next, this area is 1/2 the base. Even though it is -1, the length for this is 1. We talk about the measurement here, so it has to be positive. So 1, the height is also 1, so that is 1/2. So both of them above the x-axis, so we say that the area, I mean, so not do that. The integral here we go from -1 to 0 is 1/2. The integral go from 0 to 5 is 25/2. Both of them above the x-axis, so both of them positive, and we add them will be 13. Right. What do you mean when we intersect on the graph? By the way, when we use are you asking about 21? Oh, you mean how do we find this height? Right. Because the function is y equal to absolute value of x. So when x equal to -1, the y values here is absolute values of -1 is of course is 1. So the y values is 1. Over here, because x is 5, absolute values of 5 is also 5. So the height here is also 5. Yeah, it's based on this function. Whatever the x values is, put in that, we have the y values. Yeah. Just want to do this quickly before we go to 26, because it is on the same topic now. Right. Yeah. Rather than write the long problem, I just give you the hypothetical idea. Let's say it. Let's say that's 4. Let's say we don't have the function, or we just have the graph like this. We are given that the area here is equal to, let's say 3. Area here is 4, and area here is equal to 5. The question is, let's say if this is the function. The question asks you what is the integral. Let's go from -1 to 4 of the function. Right. So, and that is the difference between the area and the definite integral. By the way, the homework that we have earlier, let me that on the other side of this, so I'll go back to this in a minute. The homework we have earlier, we have the definite integral, and then we have the area. This time we are given the area, and now we have definite integral. By the way, it's going to be completely different. By the way, let's start with this. First, this area is above the x-axis, so we know that whatever the integral here, actually it go from -1 to 1, it's going to be equal to 3 as well, because that is above the x-axis, so that equal to 3. Sorry. This is the green. The area is positive 4, but because it is below the x-axis, the integral from 1 to 3 of the function is actually -4. So we have the negative because it is below the x-axis. So the area is always positive, but the integral might be negative. The area is 5 here, but the integral from 3 to 4, for that, it is still above the x-axis though. So that's going to be positive 5. So if it is above, positive. If it is below, the integral will be negative. The area is always positive. Anyway, I will just collect all of those numbers. We get the integral from -1 all the way to 4. We have 3, -4, and then 5. Will give us 4. Yeah, so the area is always positive, but the integral will be negative if it is below the x-axis, and positive if it is above the x-axis. Right. So I want to compare this one with the problem that question number 33 or 41 on homework, the first question of this review. Yeah. Just quickly. Yeah. On here we have the integral negative to the area positive. Here we have the area positive to the definite integral negative. Just very clear that on the question you need to know that if the question asks for the integral or for area, the area is always positive. The definite integral could be negative if it is below the x-axis. Right. Sorry, it sound like I repeat a lot of this, but it's rather important. Right. Now we go to 26. We do have question on the chat. So substitution, because if we multiply this out, that will be a lot of work. So we start with x squared plus 1, make that u. Right, sorry. I will take derivative. I should write u prime in the middle, but multiply the dx over and then divide by the 2x. So in any substitution we need to have dx and u. Right. On this one we also have the limits x equal to 0 to x equal to 2. When x equal to 0, u will be 0 plus 1 is 1. X equal to 2, u equal to 2 squared. plus 1 is equal to 5. So the limit change as well. So let that equal to, we start with x because we still have x. U cube, the dx is du over 2x. The x cancel out. Take the 2 outside, but stay at the bottom. Of course, we forgot about the limit, did we? Sorry. Right, limit u equal to 1, u equal to 5. Yeah, so still have that. X cancel, the 2 goes outside. We just have u cubed and du, right? And that will be u to the 4th over 4. And we go from 1 to 5. So we have 1 over 8 u to the 4th. Evaluate from 1 to 5. Now we're going to put 5 in u, put 1 in u. So we have 1 over 8, 5 to the 4th, minus 1 over 8, 1 to the 4th, which is still 1. So back to calculator again. Right. So first 5 store into x, and we have 1 8. If we can use the fraction alpha y equal to, like that. Oh, sorry. We just use 1 8 times 5 to the 4th power. Change the fraction. 625 by 8. And this is just 1 over 8. So we have 624 over 8 is that evenly. Yeah, 78. So that is 26. Let me, yeah. Right. We have homework question 7.3, number 5, C and D. Right. Yes, I do want to do some problem with the estimate the area using estimate the area under the curve using rectangles. So let me type that homework 7.3, 5, C and D. Right. Look. Right. Let me write out the problem first. Uh, you only have question on C and D, meaning, oh, in order to answer C, we have to know A and B because C is the average of A and B. So pretty much we have to do everything as that assigned. N equal to 4 rectangle. A, use the right endpoint. Good, because definitely we need to use the calculator of this kind of problem. Right, first, of course we need to say the question that says from x equal to 2 to x equal to 4. Sorry, that's important. First, since all this problem we have the same interval from 2 to 4 and 4 rectangles, so the width for all of this problem will be the same. The width is b minus a over n. So for this particular problem, we have 4 minus 2 divided by 4 rectangles. So we have 0.5. So the width is 0.5. Right. After that, if we use the right endpoint, the interval is, we do not need to graph the function, just need to draw the interval that goes from 2 to 4. And since we divide into 4 equal segments, so we have to cut this into 4 pieces. So that will be 2.5 here, 3, and 3.5. The first question we using the right endpoint. So from 2 to 2.5 we use this point. From 2.5 to 3 we use the right endpoint, the right endpoint, and the right endpoint. So pretty much for each interval the right endpoint give us those values of the function. And then we just find the values of those functions. The values of those functions give us the height, and then we multiply with the width. The height here multiply with the width. So whatever the point we have will give us the height, and the width is that, and so we have that. Right. I will factor out 0.5, and then inside we just have f of 2.5, f of 3, f of 3.5. Right. So yeah, we don't need to do using the calculator on this one. Turn the calculator back on. Right, so notice we need the function at 2.5, 3, 3.5, and 4. So first I'm going to store, hit the second, turn it on first. second, the curly bracket 2.5. By the way, I think I'm only do this one in D because all of this kind of the same. 3.5 and then 4, close the curly bracket. So we have 2.5 will be 2.5, 3, 3.5 and 4. Hit the store key into what L1. L1 is above 1, so we hit second and 1. So we have that. The function is 2x plus 5, so we have 2. Instead of x, we use L1 plus 5. We have those. Of course, we can add all of this by hand, but if you want to use the calculator, it's second and stat. Go to math, option number 5, and then to get to the answer, we hit second, negative sign. We have 46. Right. So that is the right endpoint. For the left endpoint, we'll do the same thing, but the point will be 2, 2.5, 3, 3.5, and whatever the values is, you average with this. That value is plus 46 divided by 2. Right. We'll go to D instead. Get back to the calculator later. Right. D, we use the midpoint. We have again from 2 to 4. The width is still 0.5. We divide this into 4 equal segments. So all of this is still the same. However, we use the midpoint, meaning that for each of the interval, we use the midpoint here. So that point is 2.25, 2.75, 3.25, and 3.75. To get the midpoint, of course, we add those two and divide by 2. So 3.5 plus 4 divided by 2, you have those are the points. From those points, we will evaluate them, give us the height, and multiply by the width. We have the rectangle. By the way, we're getting close to the end of the video. If you have any question, please ask. We can factor out 0.5. We just have those functions. Right. Now back to the calculator. Right. Of course, what we did earlier was not. I think we forgot one important thing. It's very important. Even though we add all of this is 46, that is perfectly right. I forgot 0.5 here. Sorry. 5 times 46 is equal to 23. So it should be 23 because the width here is not equal to 1. It is 0.5. So that is very important. Don't forget the width. Right. Calculator back on. Right. Now the values that we store on the list, second parentheses, are those 2.25, 2.5, sorry, 2.75, at 3.25 and 3.75. Oh wait, I don't like to look here, so let me switch calculator real quick. I mean, a list, change the mode. Sometimes the classic view like this is better. We'll see. 2.25, 2.75, 3.25, and 3.75. Yeah. Sometimes we, in the classic view, we can see the whole list. That's what I prefer. We store into a list. Still not a whole list, but at least I can check. Right. So those values. The function is 2x plus 5, so 2 times second L1, second 1 for L1 plus 5. So we have those values. Now we just need to add those values. So second stat, go to math, option number 5, second negative sign for the answer, and 44. This time I remember that there's the width of 0.5. It's very important. So we have 0.5 times 44, so the answer is 22. Yeah, it should be that. Yeah. Only do A and D because B and C we kind of the same thing, but do a lot of different points. Right. Right. Of course, this question similar to 18 and 19 on the left. So, sorry. Right. Should we have any other question? If not, I will do number 14, and then we finish the review. Right. Sure. This is a substitution. So let u equal to 7x squared plus 3 take derivative. I'll be 14x. I should write u prime in the middle. That's just u prime. But we have another one. Right, again. So we take derivative. Once again, if you have any question, please put on the chat. Otherwise, after this problem, we will finish with the review. So we'll move the dx over and divided by that, we have du over 14x is equal to dx. Yeah. So that gives us dx. We have x over bottom, we have u to the fifth. Dx is du over 14x. Cancel the x and then bring the 14 outside of the integral. We will have, because the 14 outside first, need to put 1 on the top though. Then we have 1 u to the fifth du. The x cancel out, the 14 goes out, so just that. The integral will be simple. Think if we write u to the negative 5 instead. So we have 1 over 14. U is power rule, so negative 5 plus 1 will be negative 4 over negative 4 plus c. This doesn't have the limit, so must have the constant c. Right, multiplied, we have 14 times negative 4, so we have negative 1 over 56 u to the negative 4 plus c. U is 7x squared plus 3 to negative 4 plus c. So yeah, so that is that. Yeah, we just give the answer in that form. That's good enough instead of the one we have on the back curve. We have on the key. Anyway, so it looks like we have no more question. So I'm gonna end the video here. But if you have any question, we still have time from here until Monday night. If you send a question from here until, let's say, Saturday or Sunday, I will reply to your email with the solution. But I think the video did cover quite a few problems. Anyway, thank you very much to join the live stream, and thank you very much for watching the live stream. And if you are not watching the live stream, of course, also thanks for watching later. This video will be there, but it might be a few minutes the delays between the live stream and then the video uploaded. But after that, it will be there. Thanks for all the questions. Thanks for watching, and see you on Monday for the test. Have a good evening.